Hi, I'm Przemek. I'm a software engineer at Software Mansion, and today I will tell you about how we are bringing cross-platform graphical applications to Eclipse Oniro and OpenHarmony through React Native. So let's take a look at the agenda. First, I will introduce my company. Then I will tell you about React Native. Third, I will tell you about OpenHarmony, HarmonyOS, and Oniro. And lastly, we will combine point 2 and 3 to talk about how we are bringing React Native to OpenHarmony. So, hello OCX 24, it's Software Mansion. And we are a Krakow-based software agency with a team of more than 300 people, with a growth of 30 to 40% each year with no marketing spending. Most of our clients are from the States, but we work with companies from all over the world. And we are React Native experts. The open source tools we create are downloaded more than 3 million times a month. We lead the industry in the adoption of a new experimental architecture called Fabric, and we are partnering with Expo to bring first-class support to their beloved community framework with features like over-the-air updates. And most importantly, in the context of this talk, we are bringing React Native to OpenHarmony and Oniro. So, what is React Native? It's a cross-platform UI framework for building apps, both mobile and desktop. And ideally, you should be able to do that with a single code base, though it depends. And it's also a cost-effective way of creating apps using JavaScript and React. Well, React. The most popular JavaScript library for building UIs. In the 2024 Stack Overflow survey, out of 48,000 respondents, almost 40% have used it in the past year. And when you want to build UIs in React, you basically create components or use the already existing components from component libraries, and you use HTML tags. You can pass props to your components, and your components can contain state. In this example, we have some search bar, and we basically save in the state the search text. And you write your UI in a declarative way using JSX. You can have your own components there, and you can have HTML tags there. So with React's huge community, and if it's being quite nice to develop web apps with, maybe it would be good to develop also mobile apps with it. But there are some limitations, because web and native aren't the same. When you run web apps on mobile, sometimes they just don't feel right. The loading times might be too long, or they just might not be as smooth, or you just don't have those little small details which make a platform unique. So you might not have access to the proper APIs, which are native. And different cross-platform frameworks basically handle it in different ways. So, for example, Ionic uses a web view, and it basically renders apps written in, for example, React or just plain HTML. But you also have plugins available which allow you to use all the native APIs there. Flutter, on the other hand, you write there your UI in a declarative way, and then Flutter renders your UI with its own, depending on the platform. It either uses Impeller as the graphics engine or Skia. So it's kind of similar to how game engines work. And well, React Native, it handles it in a different way. Because in React Native, you write your UI like in React using JSX, but you use mainly core components provided like React Native, for example, like text in this case. And when you create your component tree on the JS side, what the framework does, it basically creates corresponding component tree using native views, using host native views on the native side. So for example, in this case we have text, and on Android it is rendered as React text view, and the React text view, it basically extends app compat text, which is from Android's, I think, widget.text. And in the case of iOS, UI kit is used. And in React Native, most of the HTML tags have some corresponding component in React Native. For example, for div, you have view. For p, you have text. For image, you have, well, image, and so on and so on. So what the React Native team tries to do is to support most of the web APIs. And here's some example React Native code. It's the app I have shown you 2 slides ago, so this one. And what we have here is basically a view which wraps all our other components. We have an image background which shows the React Native logo in the background. We have a text saying hello OCX. And we pass some props there. We also have style sheets, which I didn't show in this example. And we also use a hook from React. This one is provided by React Native. You use window dimensions, and it allows you to just get the dimensions of your window, and it will update when you rotate your phone, for example, from vertical to landscape. So quite useful. But, well, how you develop apps is one thing. But for a framework to be successful, you also need to have a good community. And React Native has a huge community with over 2.5 million weekly NPM downloads, almost 120,000 stars on GitHub, and thousands of third-party packages. So lots of developers use React Native for their own apps. Lots of developers love React Native, and lots of developers develop their own packages for React Native, which is quite useful. Some of these packages have been developed by us. We, for example, have one for gestures, for animations, for navigation, and for handling SVG content. And these help you make your apps. These help you to make your apps. And there are also a lot of apps already are using React Native. Well, React Native was created by Meta, so it's natural they use it in their own apps. Also, Microsoft uses it heavily. And then there's many other brands which also uses it. And you probably have one of these apps on your phone. Maybe if you're lucky, you have the Tesla app. And some of these apps are built completely using React Native. Some of these apps are built using native frameworks, and then a part of them is in React Native. But that's it for React Native, and let's talk now about operating systems. So first, OpenHarmony. I won't go into much detail because there have been other talks talking about it. But generally, it's an open source project launched by the OpenITOM Foundation. And the goal is to build an open source distributed operating system frameworks for smart IoT devices, for different IoT devices, because you could have a fridge running OpenHarmony, you could have a car running OpenHarmony, and you can have mobile phones running OpenHarmony. And on OpenHarmony, you have ArkUI. It's the default UI framework on OpenHarmony, and it supports both a declarative development paradigm and a JS-compatible web-like development paradigm, which makes it easier for you to transition from web development to OpenHarmony. And in the development paradigm, ArcGIS is used. It's a superset of TypeScript. It's kind of similar to Swift UI from iOS. And here's an example. So you basically have a struct index. You have a build method where you construct your UI. You have some text with hello world. You can set some properties. You also have state, like in React. And starting with OpenHarmony 3.1, an imperative AP is also available. This is very useful for framework developers who depend on ArkUI because it allows you for more fine-grained control and for better performance. Then, based on OpenHarmony, is HarmonyOS. It's a proprietary HarmonyOS-based operating system developed by Huawei. And the relationship between HarmonyOS and OpenHarmony is similar to Android and Android open source project. So we could call HarmonyOS a distribution of OpenHarmony. And there are already devices running HarmonyOS, and it's even available in an open beta in China, I believe. So you can already test it. And then there's Eclipse Oniro. So it's the motto is the open source operating system that provides you with a platform to think global and code local. So basically an OpenHarmony compatible distribution full of European innovations and compliant with new regulations. And it has been established through a collaboration between the Open Atom Foundation and the Eclipse Foundation. And Eclipse Oniro basically extends OpenHarmony, adding some goodies, some nice things to it, like Eclipse Canto, Eclipse Theia, or maybe React Native. And its key concepts are adaptability, modularity, collaborativeness, and market readiness. So when it comes to Oniro OpenHarmony interoperability, we basically have OpenHarmony developed by Open Atom. We have the Oniro specification developed by the Eclipse Foundation. And then you can have OpenHarmony distributions, which are OpenHarmony compatible, and Oniro distributions, which are Oniro and OpenHarmony compatible. So when it comes to operating systems, they on their own, they aren't that impressive. I'm sure a lot of you have at least some apps on your mobile phones, on your computers, which you use on a daily basis. And I'm quite sure that many people, when they decide for buying a device, they look at the apps available. So having many apps which are many useful apps might be the difference for an operating system between failure and success. And React Native can help for Oniro, OpenHarmony, and HarmonyOS with that. The motto of React Native is learn once, write anywhere. So basically, developers who learn React Native working with Android, iOS, they should be able to create apps also for OpenHarmony. And React Native, it started basically with two core platforms, with Android and with iOS. They are part of the core API. They are supported by React Native out of the box. But after some time, new platforms have appeared. For example, Microsoft, they created React Native Windows, they created React Native macOS, which enables you to run your apps on Windows and macOS. There's also React Native Web, and there are applications like, for example, Expensify, which is an open source app. You can view it on GitHub. They support all the platforms listed here. So it's with one code base. So we could also add one more platform, actually more platforms, but base OpenHarmony. Oniro OpenHarmony. So how can we do that? Let's look a bit more at React Native internals. So basically, we have three main layers, three parts. Some of it is platform specific, and some of it is shared code. So when you develop your app, you write mostly in JS. So you write your application code. And in your application code, you can use some JavaScript modules, which are provided by React Native. And they can provide you some native functionalities. For example, they can provide you APIs like for changing status bar color, for vibrating your phone, or for network connectivity. And then there's the React Framework JavaScript code. On the other side of that, we have the platform-specific code. So you need to provide some application entry point, which will start your application, which will initialize React Native, which basically will be it needs to be written in native code for that specific platform, like any other application on that platform. There's also the native renderer, which renders your UI using the different native views. And there are also the platform-specific native modules, which are called from the JavaScript modules, and and in the platform-specific native modules, you call all the native APIs you want, all the native APIs a platform provides. And you also can write your own native modules. And then between these two layers, there's the C++ layer with the Fabric renderer, with the cross-platform native module code. So it's mainly a glue layer, to be honest. So looking at it another way, React Native is based on React. In the case of React, we have the React.js framework, and then underneath that, we have the React DOM renderer, which basically it transforms our JS code or JSX declarative UI into into a tree of native views, and then it uses different operations like adding nodes, removing nodes, updating nodes to create the document object model we want based on our JavaScript code. And in the case of React Native, it's similar. We have the Fabric renderer, and we have then the platform-specific renderers. So basically, what we need to do is to provide an ArkUI renderer, which will basically do all the graphical work in ArkUI. So now let's look a bit at the rendering pipeline of React Native. It generally consists of 3 phases. It's the render, commit, and mount phases. In the first phase called render, what we do, React basically calls all the JSX components, which are functions, and constructs an element tree with that. And then, using that element tree, a shadow tree is created here in the middle. And, well, the shadow tree represents all the host views on the native side. Because in React Native, you can create your own components, and you can use native views, host views. So these host views have corresponding views on the native side, but you can also wrap them with your own components, and your own components won't have corresponding views on the native side. So in the render phase, React Native basically creates a shadow tree with all the host views. So when you have a view with a text and some other views, a button, the wrapper view won't necessarily get a shadow node, but the view, the text, the button, they will get one. So that's for the rendering phase. Then there's the commit phase, and in the commit phase, mainly, well, a couple of things happen, but generally one of those things is layout calculation. Layout calculation is mainly in C++. It uses React Native's own layouting engine called Yoga. And it basically analyzes the styles you get from JS and layouts based on that. But there are also some calls to the native side, because things like text need to be measured on the native side. And then you have basically the mount phase. And in the mount phase, the trees are diffed. There's a diff calculated between the different host view trees on the native side, and the native renderer basically applies different mutations to the host view native trees on the native sides, depending on what you need to change. So that's one thing, drawing things on the screen. There are also two more things you need, mainly one thing we need for an app. It's interactions. So in React Native, you can have different callbacks for your views, like on touch, on click, on long press, things like that. So what we need to do is, for our views on the native side, we need them to react for clicks, and we need to emit those events to the JS side. So with that, we can have actually interactive applications. And then what we also need to add is the different React Native modules, turbo modules, so, which will add us different functionalities which depend on the native side. Because, for example, networking, it's not handled by the JS engine, because the JS engine in React Native, it just runs the JS. So when you want to do fetch or XML HTTP requests in JS, what actually happens is React Native polyfills those APIs in the JS, and they call native methods, which then use native APIs for networking. There's also turbo modules for like status bar, vibration, for showing alerts, many different things, basically. So when we have these three things, we actually can get really usable apps. And well, we implemented those things. And we have React Native OpenHarmony. So it's a library basically bringing React Native to OpenHarmony-based OSS. It was developed focusing on Harmony OS. It's currently using Harmony 5.0 APIs. So these APIs are quite new, but we really needed them to support all of the different functionalities of React Native. And we originally used ArkUI's RTS declarative development paradigm, but later we switched to the imperative C API because it allowed us to improve performance by like 40% or even 50%, which is quite a lot. And when it comes to RNOH current status, almost all core React Native APIs are supported, and around 300 applications have actually been published in Huawei's app gallery for Harmony OS. And some of these apps are quite huge. For example, Ctrip, it's it's like trip.com, but it's trip.com for the Chinese market, or Meituan. And these are very large in the Chinese domestic market. So there are also some problems which need to be solved yet, because we still aren't open source, actually. We are slowly getting there. We are working on that. But we need to improve things like developer experience. And we need to create a better documentation. But we are getting there. We are working on that. And for Eclipse Oniro support, we need to wait for OpenHarmony 5.0 adoption. Because I believe Eclipse Oniro is still based on a bit older version. But we already managed to make RNH work on Eclipse Oniro last year ago. That was an older version, but the new version, it needs OpenHarmony 5.0. So when you want to use React Native in your own apps, on other platforms, you either start a new project basically with a single command. You can use pure React Native, or you can use Expo, because some time ago, React Native introduced different ways of, basically React Native is the base framework, but you can also use something called a React Native framework, like Expo, which adds you different functionalities and which expands the React Native a bit. So for example, now the default way to create an application is using Expo. And with that, you can get some really useful features like over VR updates, or you can run your app just by scanning a QR code. If you update your JS, if you update your native code, you will have to recompile it. And you can integrate React Native with apps which are already existing on Android or iOS or on other platforms, which is called Brownfield. And there are very big projects which do that. For example, the company Expensify, they have a very big app. They have their old app is written natively on the platforms, for example, in Java for Android. And they created a new app with new functionalities. And you can basically, when they integrated those apps, and on the old app, they just create a new screen, And that new screen contains the application entry point for React Native. So when you navigate to that site, you can use React Native all you want. And when it comes to React Native on Harmony OS, well, firstly, it's still not public, but you can get access to it. So the end goal is to be able to create new projects with a single command, just like a normal React Native. But we still need to work on that. And ideally, migrating existing React Native apps should be easy, but it depends on the app, because some apps, they are mostly JS code. So the JS code will work everywhere. But then there are always many apps also use libraries which contain native code. So for these apps to work, you also need to have the native code rewritten for OpenHarmony in ArkUI. And how easy it is to run such an app on OpenHarmony depends on what types of libraries you are using. Because some libraries, they will probably already have been ported, libraries which are used often by many people. And there's actually, I believe, at least several libraries which are already ported. But then you have apps which contain a lot of native code, which use some rarely used libraries. So migrating these will take more time, because you will need to rewrite almost all of that code. So that's it for now. Thank you. To summarize, I believe that React Native can be very helpful for OpenHarmony and Harmony OS and Oniro. And I'm interested to see how it goes in the future. Here's a QR code for my socials and the company website. Thank you. And if you have any questions, feel free to ask them.